Hi there, welcome to this lecture. Now we're going to go over the hash table data structure in Java, all right? And you should already have this code, and this is a later lecture that I uploaded, so you may have to update your source code to make sure that you have this ds.hashtable package, okay? So just go back to the beginning of the course and make sure you download the latest source code in case you don't have it, okay? So you should see this ds.hashtable package. You should see ds.heap implementation package. You should see the ds.binary search tree package. These were added later. But anyway, let's get started on the hash table class. All right. So I also have this app class. Let me open that up and show you that it just contains the main method. We're just going to be testing our hash table data structure in this class. So we'll get to that later. So let's get started coding this hash table data structure. The first thing we need, of course, is the underlying array. Right? Hash table utilizes an underlying array container, right? And so what are the kind of elements that we're going to be storing in this array? We can make that decision right now. How do we intend on using this hash table data structure? Do we want to insert numbers into it? Do we want to insert objects of other types, user-defined types, or do you want to store strings? For this example, I'm just going to keep it simple and just get the basic functionality working with strings, and you can always extend this to use other data types as well, okay? So we're going to be able to put words into this hash table and get words back, all right? And we can also enhance this data structure to be like a dictionary where you not only do you put the words in the hash table, but you also put the definitions of those words and sort of create a dictionary out of this, okay? So the first variable is the hash array. This is the underlying container. This is the array in which all the data is going to go into. And then I'm also going to define a variable called array size. And this is going to be used in multiple places in the code. And then one more thing, I'm going to define a general variable, and we'll just initialize it to 0, and that's just the size. This is going to be a counter, all right? Counter for the number of elements in the hash table, okay? So the array size is the number of slots available in the entire array. The size is the number of elements that are in that array, right? The number of slots that are used up in that array, right? So it's important to make that distinction here. So every time we're going to be inserting data into this hash table, we're going to be incrementing the size variable, okay? And you'll see that action later. But anyway, first let's create our constructor. So it's going to be a public hash table, and it is passed in the number of slots that the user intends this hash table to have, right? The number of slots we need in the array, right? Again, one disadvantage of using the array as the underlying container is clients of our data structure should know how many elements they expect. The number of slots cannot be changed because we're using an array underlying container, right? There are fancy ways of doing it, and we'll get into those later, not important. We talked about that in the array list data structure, increase the size of the array, but we're not going to go there right now. Let's get the basic functionality working. So the first things first, we need to initialize the hash array with the proper number of slots. And so that's going to be a new string, and then we pass in the number of slots like that. Okay, so there we initialize our data, our underlying container. So once that array is initialized, then we're also going to assign the array size variable the number of slots that we were able to initialize the array with, okay? Now recall that, in the previous lecture, I spent time explaining about why it's so important to have a prime number as the array size, all right? So if you've got an array that has a size that is divisible by some numbers, that is no good. It cannot be divisible by any number. It must be a prime number size. So to ensure that we initialize an array of a prime number size, I'm going to put in some logic here. And we'll define these methods in just a minute, but we'll say where if is prime, all right, if the number of slots that were passed in, if they were prime, then we're going to do this. Let me just cut that out and paste it in here. Then we're fine. We're ready to rock and roll. We'll do this. Otherwise, else, we need to get the next available prime number. How do we do that? I'm going to utilize a method called getNextPrime, and we'll define these methods in just a moment. So getNextPrime is going to give us the next available prime number, bigger than the number of slots. So that's how we're going to use that. And right now, of course, Eclipse is complaining because I haven't defined these methods, and that's okay. We'll get to that in just a moment. But let's initialize a variable called prime count. So this is going to give us the next available prime number. And then, of course, we need to initialize the hash array, right? So let's paste that code here, and instead of a number of slots, we're going to create the array with the prime number, which is prime count. And then let's also change the array size to be the prime count. And now I need to let the user of this data structure know that, hey, you were trying to create an array that is not a prime number. Print line statements that the hash table size that was given is the number of slots, right? That's what the user passed in to the constructor. And we're going to say that that's not a prime number, is not a prime number, okay? And then I'm just going to do a similar thing. Let's just also indicate what the size was changed to, and that is prime count. So let's just do that. Let's get rid of all of this and just say that hash table size changed to the prime count. And there we go. In the constructor, we're able to ensure that we're creating an array that is of a prime size, okay, prime number size. So outside of this constructor, let's now start defining these methods, is prime and get next prime, okay? So the first thing is we're going to create a, well, actually it's going to be a private method because it's only being utilized in this class. And let's say that it's going to be returning a Boolean, right? We're checking for is prime, is it going to return a true or false? So it's going to be returning Boolean, and let's define the method name as is prime. And it takes an argument, the number that we're trying to check to see if that number is prime or not. And so we'll have a loop where int I is equal to 2. And so I times I, right, which is going to be 4, 6, 8, whatever, is less than or equal to the number that's passed in, okay? And we're going to increment I by 1 every iteration, okay? And this is going to continue to happen if modulus I is equal to 0, then that means it's divisible, right? There's no remainder. So we need to return false. Okay, otherwise, outside of this loop, otherwise it's just going to be return true. And make sure we put 2 equal signs there because we are doing a comparison. Okay, so the number mod I, if that returns a 0, then that means it's not a prime number. There is no remainder, so it's divisible, evenly divisible. It's going to return false, otherwise it's going to return true. So that's is prime. So we got one method out of the way. Now, how do you get next prime number? Well, that's actually going to be even simpler. Let's just also define this method as a private method, and it's going to return an int to get the next prime, like that. And so the argument is going to be the minimum number that's passed in. So this, of course, the number that this method returns is going to be larger than the number that was passed into it, right? It's supposed to give us the next available prime number, which is, of course, going to be larger. So in this loop, we're going to have another loop in here where int I is equal to the min number that was passed in. And this is going to be an indefinite loop. So true, always. And then we're going to I plus plus, and I'll show you how we can break out of this loop. If the number that's passed in, if that's a prime number, so we'll utilize this method that we've defined already up here. If I is prime, right, then we just return I. Okay, so it's going to continue to increment I until I is a prime number, and then we're going to return I. And that's how this method breaks, and we're able to exit this with a valid prime number. So we've got is prime and get next prime working, and so our hash table constructor is complete. Okay, now moving on to the hashing functions. So remember, with double hashing, we need 2 hash functions. The first hash function is going to give us the ideal position in which we'd like to insert the element into, right, in the array. All right, that's going to give us the index position where we would like to insert. That's the first hash function. The second hash function is going to give us the step size You know, in case where the index position where we would like to insert is already taken, the hash function 2, the second hash function, is going to give us the step size, the number of steps we need to take to find the next open address, the next available slot. So we need 2 functions. So let's work on the first function first. So it's going to also be a private function or method in Java to be language specific. So private int hash func1, and the argument is of course going to be the word that we want to insert. Okay, and so we need to convert this string into some numeric index position. How do we do that? Well, Java has a very cool hash code method. All right, so you don't even have to worry about how to convert letters into numbers or anything like that. It does that in the background. So we can save that into this variable called hashval. And so we can do word.hashcode. All right, so when we invoke this hashcode method on the word object, it's going to give us the hashval, right, the numeric thing that represents. Now, the next thing we need, if you recall from the overview lecture from before, we need to do the mod operator with the array size. So we could do hashval is equal to array size mod hashval. Excuse me, this should be before mod array size, like that. Now it's important to know that Java can return negative hash codes. Okay, that's just part of the language. It has a very big range of the kind of numbers that it can return for the hash. So we need to check for whether hashval is less than 0. All right, and if it is, then we're going to do hashval plus equals. We're going to increment the array size. And then outside of this if statement, we're just going to return the hashval, whatever hashval we were able to generate. Okay, so this is the ideal index position. Let me put that here. Ideal index position we'd like to insert or search in. Okay, now if this is populated, we're going to need another function, and that's going to be called hashfunc2. That's going to give us the step size, the number of steps we need to take in order to find an available slot. So I'm just going to copy this method definition because it's almost the same, and we'll call this hashfunc2. All right, and that's also, of course, going to take the word. So the word that we want to insert or search in the hash table needs to be passed to both of these functions. All right, hashfunc1 as well as hashfunc2. So how do we deal with hashfunc2? Let me just also comment that this is going to return step size. And this function right here returns preferred index position. So in hashfunc2, let's get the hash code. So we do word.hashcode. And I'm just going to do int hashval. So up to this point, it's pretty much exactly the same. We're doing the same thing. Remember, this function cannot return the same value as hashfunc1, and it needs to return something larger than 0. Okay, so we need to ensure that we're doing that, because if we have a 0 step size, that means we're not taking any steps. We're going to run into collisions, and the loop will run forever. The next thing is we need to do hashval percent equal, which is mod equals array size, like that. And what does this mean? Mod equals meaning hashval. Let me change this so that's easier to read in case you're not familiar with that syntax. Hashval mod array size is equal to hashval. Okay, so we're doing the mod and we're reassigning it to hashval. And then if, this is important, if the hashval that was given to us by the hashcode function, if that's less than 0, then what we need to do is increment hashval plus equals array size. All right, so we're appending the size of we're increasing the size of hashval by the array size. And now for the step size, we haven't taken any steps yet. How do we determine the step size? Research shows that you can use a prime number that is less than the array size. All right, so we can just stick with something like 3. So we'll do return 3 minus hashval percent or mod 3. like that. And this will give us the step size that we want. All right, so the number that you choose here, this could be, for example, 7. We can also do that. This could be 11. So they must be prime numbers that we chose here. But it must be smaller than the array size. So the reason I'm choosing 3 is so that, it's a small enough number. The array size is probably going to be a lot larger than 3. We're at the mercy of the client that's using this data structure. We can put checks in our code to ensure that, but that's for later. Maybe you can try that as an exercise. That's not important, as long as you get the idea that this number that we pick must be smaller than the array size, and that the value that this function returns is greater than 0. Okay, so over here I'm just going to add to the notes here, return step size greater than 0. Very important. So now that we have the 2 hashing functions in place, the next thing is, of course, in order to use this data structure, we need to be able to put data into it, right? So let's define a public method that doesn't return anything. It's just going to return void. Insert the word that we want to put into the hash table, right? And so we'll invoke the hash func1 method. We'll pass in the word, right? And we'll also pass that word into hash func2, and we'll get 2 values. The first value is we'll just call that hash val, or preferred index position, whatever you want to call it. And the second value is step size. Let's make that capital S so that we're using camel case. And now we just need a while loop where the hash array at the given hash value that we are checking in, if that's not null, meaning that there is data in that address, in that location, then we need to do 2 steps, right? This is that while loop that I talked about in the previous lecture, towards the end of that lecture. All we have to do is increase the hash val plus the step size. And then the next thing is we do hash val mod array size. And we'll assign that back to hash val, like that. This is going to continue to happen until we find a null position in the hash array, until we find a slot in the hash array to put our data in. Next thing, we need hash array, right? When we exit this loop, that means we found a position to put our value in, right? And what is that? That's going to be the hash value. So at that index position, we put in the word that we are trying to insert. And then I'm also going to print to the screen that we inserted word. And what is that word? We're just going to put that so it's easier to document. And then I'm also going to increase the size of the hash table. How many elements have been inserted into the hash table? That's what this size variable represents. Okay, so we're done with the insert. Now let's worry about searching for a value in the hash table. Let's define a method called find. That's also going to be a public method, and it's going to, let's just say it's going to return the string, the word that we find back to us, right? It's going to return that. So the argument is, of course, word, the word that we are trying to search for. And you can, of course, enhance this method so that it returns a definition of a word or some other attribute of the word or object. For now, we just want a basic functionality. We want to be able to insert those words and get those words back using find and insert, okay? So that's what this method is going to do right now. So to find elements, we do exactly the same thing we did up here, right? So let's call both of those hash functions, okay? So the next thing we need is pretty much the same thing, what we did up here. So we're using the same exact strategy in both of these situations for inserting and for finding, right? The way that we go about inserting our element into the array and the way we go about getting the element back from the array is exactly the same. We get these hash values in the step size. They're not going to be different for inserting or getting data back. They should be the same, right? That's the whole point. Otherwise, you're going to get inconsistent results for putting things in and getting things out. So we need to make sure we're using the same strategy. So in this case, there's a minor difference. So while hash array at this given index position, if that's not null, right, that means there's some data. Now let's check if that data is the word that we were searching for. So we can have an if statement within this while loop, and we could say we're hash array at the hash val position is equal to, we're using the equals method in Java when we need to compare strings. There's this dot equals, right? When we need to compare objects, we can use dot equals. This is only used for strings and objects. Just keep that in mind. If it were integers, we could just very easily use double equals, but we can't do that with strings or objects. So inside of this if statement, if we found the word that we want, we're just going to return hash array at that hash val index position, just like that. Okay? Otherwise, we're going to do exactly what we were doing before. We're going to keep incrementing the step size, and then we're going to figure out the new hash value with this mod operator against the array size. So once we exit this while loop, what happens? Well, that means we were not able to find what we were looking for, and so we're just going to return the hash array at that hash value, which is most probably going to be null. And there we go. This is our code. Not too bad. Hopefully you were following along and you're able to code with me. Make sure you're coding everything as you're watching these lectures. That's very important to me. That's the best way to learn. So now let's test whether this data structure is working. In the app class, I've already got some code written that you'll find in your source code as well. But let me just paste that in here, where we're able to test this data structure. So here we're creating a new hash table with size 19. All right. This is important. We need to know how many elements we expect this hash table to contain. This is a prerequisite for using the hash table data structure. This is probably the only real downside of this because, of course, hash tables are not resizable by default. You need to actually implement resizing of the array by creating a new array and then copying those elements over. And that's just, how that works with the array list. But at its basic form, we are not going to be increasing the size of the array or anything. We're just going to be utilizing the array that we have. And for that, we're just saying that it contains 19. Okay, so we're at the mercy of the client to know how many elements they expect the array to contain. Okay, so in our case, we're doing 19. So we want to make sure that we don't put more than 19 elements. And here, I think there's 12 of them. So we're inserting all of these words. And then down here, we're finding those words. So we need to be able to find these words back, all right? And that's how we know that our data structure is working properly. So when we try to search for apple, it better return apple. It shouldn't return Africa or speed or any other word, all right? So let's hit play. And notice we were able to insert all of these words. And then when we're trying to find these elements, we're able to find apple. And here it says null. So zebra is returning null. So let's make sure that zebra is not in this list. And if you scroll up, was zebra ever inserted into the hash table? No, it was not. Okay, if you look through this, there's no zebra there. So that's good. This is working as expected. And then the rest of the words are being returned properly. Now, if you want to get a visual as to how this data structure looks with these elements in it, you can display the data in the hash table. Okay. And I'll just define a method here real quick. Rather than leaving it as an assignment, this is going to be very simple. We're just going to do public void display table, and it's just going to print, using print line statements, the contents of the array. So let's just print, we'll just say table, and on the next line, we're going to do a for loop where int I is equal to 0, I is less than the array size, right? We want to make sure we don't go out of bounds. And then I++. So as long as that's the case, we're going to print the contents of the hash table. So if the hash array at the ith index position is not null, right? If that's the case, then that means we found a word, right? So let's print out that word. We're just going to say hash array at the ith index position. And I'm just going to put a little space here. All right, if we are able to find a value in the hash array. Else, it should print something else. Let's just print out 2 asterisks to represent null, meaning there's no data at that slot position. Okay, and this is going to be, instead of a print line, I'll just change this to a print so it doesn't move to the next line. Otherwise, we'll see spaces you'll see what I mean when you print this out. And then outside of this else, we'll just print out an empty space. Right, so when this for loop is over, once it's done executing these commands, we just want to put a print line statement so it moves to the next line. All right, that's all that's there for. So now I've got this commented out, table.display table. So let's just display the hash table. Let me comment out all of these things. So we're inserting all of these things and we're displaying the table here. So let's right click, make sure you save those files, the code that we changed, make sure you save that code, and then you run as Java application, and boom, notice that it's showing us the contents of the array. We've got phone, and then all of this. You can see how the data is spread out in the array. Okay. Now after every word, notice that there's a space, right? Let's fix that here just to make things a bit pleasant to look at. So instead of print line here, I'm just going to change this to print. Okay, so it doesn't print something and then move to the next line. It just prints on the given line and let this guy do the print line, advancing to the next line task. So let's go back and hit play again, and there we go. Now we see an easier data structure to look at. Okay, so notice phone is towards the top, towards the beginning of the array, and then speed, and then we've got these words. So it's not a very large set of slots, right? We only got 19 slots, and we're putting 12 elements in there, so it's relatively packed, and that's why we see this kind of clustering going on. Let's see what happens if we change this to 500 slots. Let's hit play, and then notice that hello is here, and then there's no words surrounding it. Let's keep going up. Milk, speed, apple. These words are pretty separate. Okay, September, and then there's a big space, phone. So there's less clusters here, all right? So because it's a prime size array, obviously it changed the 500 to the next available prime, and it's able to spread out our words like this. Okay, so less clusters if the size of the array is much larger than the number of elements you put into it. Okay, so that's ideally the best way to utilize a data structure, the hash table data structure, is to make sure you initialize it with at least twice the number of elements that you anticipate the array to be using. Okay, this is of course an extreme case. Instead of 12 elements, I made it 500 just to prove the point and to ensure that there's no clustering going on. But hopefully you get the idea. Let's change this to 24 and see what happens. Let's hit play and notice that there's a little bit of clustering, but it's still reasonably spread out. Okay, and if we change this to 50, let's hit play. Notice that you're still going to see some clustering, but there won't be any large clusters. Now, we're not through yet with hash tables. There's one more topic that I'd like to cover, and that is called separate chaining. Separate chaining is a different strategy for implementing the hash table data structure. The code that we covered in this lecture deals with collisions, right? We used the double hashing strategy to deal with collisions. So if 3 or 4 items are trying to get into the same slot, we would move them in another open address somewhere, okay? With separate chaining, we don't even deal with collisions. We don't worry about collisions. If 3 or 4 items are competing to get into the same slot, you let them get in there. But we use the linked list in combination. So each slot is going to have a linked list of items that all belong in that slot, okay? So I'm going to explain to you the theory for separate chaining in the next lecture, and then in the following lecture, you're going to be tasked with implementing separate chaining in Java, and I'll go over that code in great detail, so it'll all make, hopefully it'll all make sense. Okay, so let me wrap it up here. Thanks for watching. I'll see you soon.